As we know, meta-heuristic optimization algorithms are becoming more popular in engineering application. We have different nature-inspired algorithms that are used to solve various optimization problems. In this video, you will learn about whale optimization algorithm, and we will try to understand how this algorithm is working step by step with numerical example. Basic details about this algorithm is given in part 1. You can check the link given below in the description box. Here, everything related to this algorithm, its mathematical model, is discussed in detail. As you can see, we have various mathematical models used in this algorithm for searching and circling and for hunting. And you can check everything related to this algorithm with various models in the part 1. In this video, we will try to understand how this algorithm is working step by step with numerical example. So step 1 is parameter initialization. Here we will initialize all the important parameters required. For example, lower bound is -10, upper bound is 10, maximum of iteration is also 10, and initial population size suppose 4. Now we will initialize the population for the 4 search agent, and you can see all the values are within the lower bound and upper bound. Now we will calculate the fitness value for each agent and find out the best solution. So in order to calculate fitness values, we require a fitness function, or you can say cost function or objective function. So here you can see we use this fitness function in order to calculate the fitness values for the search agents. So use this fitness function, put all the values here, and we got this. Now we will find out the best solution. Here best solution means minimum value, and among all you can see minimum value is here, this one. So we will consider this best solution, and the maximum value is worst solution. Now main loop for this algorithm start here. As you can see, this is the main loop for this algorithm. First we have stopping criteria. We will check the stopping criteria. If stopping criteria is matched, then stop and display the best solution that you got in the previous iteration. If stopping criteria is not matched, then we will repeat the loop again and again until stopping criteria matched. And you can see inside this loop we have, inside while loop we have for loop, and inside for loop we have if else statements, and you can see all this. So let's try to understand now how this algorithm is working step by step inside this loop. So first we will check the stopping criteria. Initially current iteration is 0, and we know 0 is less than 10. So this condition is true. Now we will update the position for the each search agent. Now we are here for I equal to 1 to population size, and population size is 4. Now we will update the parameters, and here rand is the random value, that is the normally distributed random number, as you can see here in between 0 and 1. And you can check in part 1 what is A, C and all. This we explained in part 1 in detail. So now we updated all the values here. Now we are here. Now we'll check this statement whether it's true or not. So P is here any random number, and suppose we will choose any random number, for example 0.2691. Now we will check this condition whether it is true or not, and you can see this condition is true. If this condition is true, then we'll perform this part, else this one. Right now condition is true, so we will perform this part here, and value for A is this one, and again condition is true, so update position for the current search agent. Value for I is 1, and you can see we have value for C is 1.3084. best solution is this one, 0.6, and the current position I is 1, that is this one, 1.3, and we got this one. Now put the value here. As you can see, this is the mathematical model here. Now put all the values in order to update current position, and we got 1.1495. Now again we will repeat this loop, and this time value for I is 2, so we will select any another random number for P, that is this one, suppose, and you can see condition is true, and after that here this condition is also true, so again we will update the position for the current search agent using this mathematical model, put all the values here. Best solution is this one, and now value for I is 2, so we will put the value this one. Now update the position for the second agent, and we will put all the values here, and we got this one. Now value for I is 3. We will use another random number, that is 0.3196, and you can see condition is again true. And now we will update using this mathematical model and put all the values, and we got this one. You can see current position is now 3, value for I is 3, and this is 0.6, and then we got this one, put this value here, and we got the current position for the third search agent is this one. Now we will update the value for the fourth search agent, as for this loop is 1 to 4. Now again we will repeat this loop, and this time value for I is 4, and we will use another random number, suppose this one, and you can see this time condition is false, so we will perform else part, and we will update the position using this mathematical model, put all the values, and we got current position for the fourth agent, that is this one. Now you can see we updated the position for the each search agent. After that, now we are here, check the boundaries whether all the solutions are within the bound or not, and you can see here all the values are within the bound. Now we will calculate the fitness value for the each search agent. So using fitness function again, we will calculate the fitness values for the each search agent, and you can see we have updated fitness values for the each search agent. Now we will update the best solution, and now best solution is this one, 0.6329. So we will select the minimum value among all as the best solution. Now increment the counter, and now value for current iteration is now 1. Again check this condition here, 1 is less than 10, condition is true, so again we will repeat this loop. As you can see here, now current iteration is 1 and maximum iteration is 10, condition is true, so we will repeat this loop until the stopping criteria is matched. So we will repeat this loop until we match the stopping criteria, and when this stopping criteria is matched, we will return the best solution that we got in the previous iteration. For example, right now best solution is this one, 0.6329. So like that, we'll repeat this loop until we met the stopping criteria, and when you will met the stopping criteria, we will display the best solution that we got in the previous iteration, and we can use this mathematical model to update the position for the search agents. So that's all about this video. If you have any question, you can comment below, and thanks for watching this video. All the important links are given below in the description box.